Good morning. Today we are going to be learning about radicals, and the essential statement for today is I can simplify a radical expression. So we talked a little bit about radicals this week, and we're going to dive a little bit deeper into breaking those down. So we're going to start off with some definitions. So this radical symbol, so the symbol right here is used to represent the non-negative square root of a number. So you've seen me use this week, and that is a definition of what a radical symbol is. All right, a square root. Okay, so a square root is a number that is multiplied by itself to form a product. It's called a square root of that product. So a 5 times 5 is the square. 25 is the square root of 25 is 5 because 5 times 5 is 25. An example of the square root of 36, it equals 6 because 6 times 6 is 36. And it also is negative 6 because a negative times a negative is a positive. So it's both positive and negative numbers that are the same, right? These numbers have to be the same. So 9 times 9, that's a 81. The square root of 81 is 9 because 9 times 9. Okay. And then the product property of a square root. So that means if I have two numbers, a and b, I can just break them up into a square root of a, square root of b. So if I have square root of 4 times 10, I can break that up into the square root of 4 and into the square root of 10. All right. And here are some perfect squares. I sent you guys a picture the other day of some more, so you can either use this or you can use the picture that I sent you on Google Classroom of some basic perfect squares. So we know 1 times 1 is 1. That's not going to be super useful, but I know that it's a perfect square. 4, 2 times 2. 9, 9 is 3 times 3. 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. It can go on and on and on. So let's get to some examples of how we can break down radicals. The first question you want to ask to yourself is there a factor inside 18 that is a perfect square? Or is there a factor inside any of these examples that are a perfect square? One of my favorite kind of math tricks is that if I get a little confused and I get a little lost, I know that if I add these two digits, so 1 plus 8, that is going to equal 9. And anytime this equals 9, you know that one of the factors is 9. And we know 9 is a perfect square. Okay? So that might sound a little confusing. You might have to rewind it and repeat it, but I know that one of the factors is 9, and I know 9 is a perfect square. So I'm going to break that into square root of 9 times the square root of 2, because 9 times 2 is 81. Oh, I'm going to do this first. Do my product property first. So I know the square root of 18 equals the square root of 9 times 2. Okay, and using my product property of a square root, I can break these up. So that equals the square root of 9 times the square root of 2. Now, we know that 9 is a perfect square because A, it says it right there, and we know what two numbers multiply together that equal 9. 3. So this right here is just 3. And then 2 cannot be broken down, so we just keep it as 2 square root 3. So that would be our final answer, is 3 square root 2. Okay, let's get into some more examples. All right, so 50. I'm actually going to move this up a little bit. That's fine. 50. Let's look through it. Okay, 1. Does it go in? Yeah, but that's not going to help us. 4. Something times 4 equals 50? No. Something times 9 equals 50? No. Something times 16 equals 50? No. Something times 25 equals 50? Yeah, 25 times 2. Okay, so I can break this down. Square root of 25 times 2. And I know that using my product property of a square, that these can be divided up. So square root of 25 times the square root of 2. All right. And we've just found out the square root of 25 is a perfect square. So what is the square root of 25? What two numbers that are the same multiply together to equal 25? 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. Oh, 5 times 5. So that's just 5. And we cannot break down the 2. So we're going to have 5 square root 2 as our answer. So the square root of 50 is 5 square root 2. I'll circle it just so everyone knows. Okay. Now I'm going to do one that doesn't have 2 left over. So you can either use my trick that I told you about 18. If I add these 2 digits up, 6 plus 3 equals 9. So 6 plus 3 equals 9. So I know 9 is a factor. Or you can already know that 9 times 7 is 63. Any way you want to do it, I know that 9 is a perfect square here. So I'm going to break it down to the square root of 9 times 7. And so using the product property of a square root of 9 times the square root of 7. And we know, like what I just said, 9 is a perfect square. And we've already figured that out from it being 3. So this turned into 3. And this 7 is a prime number, so it doesn't need to get broken down. So it would just stay 3, the square root of 7. So if I break down 63, it's 3 square root of 7. All right. I'm going to do one more example, but I'm going to do it in 2 different ways. All right, so let's start out. We've got 32. All right, so I know that what two factors are of 32? Let's go with 4 and 8. Yeah. Okay, so I have square root of 4 times 8. Okay, I know that 4 is a perfect square, right? So then I can break it down first by doing 4 times the square root of 8. And then 4 is a perfect square, so it goes to 2 square root 8. And you're like, oh, wonderful, I'm done. No, if you look inside this radical, you can see that 8 also has another perfect square. So we can break it down even further. So my 8, what 2 factors are of 8 that have a perfect square in it? Right, 4 and 2. Okay, now 4 and 2 are perfect squares, and I can break those up again into 4 times square root of 4 times the square root of 2. And we already figured out that 4 is a perfect square, so I have 2 root 2. So you're not done, because we don't want to forget about the 2 that we have up here. So technically, we have 2 times 2 the square root of 2. And 2 times 2 is 4. So our answer would actually be 4 square root 2. Now you're saying, Miss Stark, this seems like a lot of work. Why can't I just multiply it by something else first? You can. So let's work on what it would look like if I multiplied it by a bigger square root. So what two numbers multiplied together equal 32 that have a perfect square in it? So if I look, I could do 4, right? Can I do 9? No. Can I do 16? Yes. 16, square root of 16 times 2. And when I break that up, I've got square root of 16 times the square root of 2. All right, so when I break that down even further, the square root of 16 is a perfect square because 1, it says it up here, and 2, we already know that two numbers that are the same multiplied together equals 16. And what two numbers are that? 4. So if we break this down, it becomes 4 square root 2. All right, and see, that seems a lot simpler than going through all this mess, right? So this breaks down, still, it's the same thing, 4 square root 2. And sometimes if I'm like, I can't even remember what the factor is, but I know it's an even number, so I'll start with 2 times whatever and kind of go from there. That's what I've done before as well. And remember the little trick with 9s, I know that 9's a perfect square, so if I want to shoot for 9, that's good. If I add the 2 digits up and it equals 9, then you know it's multiplied by 9. All right, hope everyone has a great day. Talk to you guys later. Bye.